Okay, with Quicksort, we have a similar goal as merge sort, where we want to split things in half and sort them recursively. The way we're going to do that in Quicksort is using a pivot. So say I want to sort these cards. I'm going to pick the first card as my pivot, and then I'm going to split things on this side, things that are smaller than the pivot, on this thing, things that are equal to or greater than the pivot. So I'm going to go through each of my cards, and I can split them in that way. And now we can see on one side, I've got all the things less than, and on the other side, all the things that are bigger. And sort of conceptually, that element that I chose as my pivot, it is in the correct spot. And I'll use this little game piece to represent what my pivot was. Now, I've got everything on the left-hand side is smaller than it. Everything over here is equal to or bigger than it. Now I can recursively sort each side. So I'm going to do the same thing, and I'm going to pick a pivot. My pivot I've picked is 2. And I'm going to do the same thing. Everything that is smaller will go on the right. Everything that is bigger or equal to will go on the left. I've got the lefts and rights wrong, but okay. And here you can see, oh, that wasn't a very good pivot to pick because nothing ended up smaller than it. We can think about recursively sorting this side too. I'm gonna choose a sneaky pivot. I choose the pivot of 9. Okay, so that's another recursive call. Every time we choose a pivot, that's a recursive call. And then I'm gonna split it into smaller and bigger or equal. Okay, and each time we're really trying to divide it in half. That's our goal, is if we can get a pivot that divides it in half. And I can keep going through this one. I will be additionally sneaky, choosing good pivots, and then I put smaller over here and bigger over here. I can do the same thing here. I'll pick my pivot, make sure that I keep these all together, smaller and bigger. And you can imagine that I am going to be hitting some base cases here. There. Okay, so we've made a bunch of different recursive calls, but the thing that has happened at each stage is we've gotten some relative ordering. So remember when we had the 6 and we had all the things smaller and bigger, it was like in the right spot. And similarly, we have been able to do that same thing. We knew the 2 needed to go all the way on the right because nothing was like to the left of it. Nothing was smaller than it. And if we imagine that a 2-element array is our base case, we can sort of slide things back into the correct location. That was bigger than all of these. And things end up sorted just using that algorithm. And you can see each of the recursive calls I made, and that was the pivot. And so the pivot we put into the right spot, divided things up into smaller than, greater than or equal to, and then we're able to make a recursive call on that.